It'll be good to introduce some basic terminology that is commonly used in artificial intelligence to distinguish different types of problems. The very first word I will teach you is fully versus partially observable. An environment is called fully observable if what your agent can sense at any point in time is completely sufficient to make the optimal decision. So for example, in many card games where all the cards are on the table, the momentary sight of all those cards is really sufficient to make the optimal choice. That is really in contrast to some other environments where you need memory on the side of the agent to make the best possible decision. For example, in the game of poker, the cards aren't openly on the table, and memorizing past moves will help you make a better decision. To fully understand the difference, consider the interaction of an agent with the environment through its sensors and its actuators. And this interaction takes place over many cycles, often called the perception-action cycle. For many environments, it's convenient to assume that the environment has some sort of internal state. For example, in a card game where the cards are not openly on the table, the state might pertain to the cards in your hand. An environment is fully observable if the sensors can always see the entire state of the environment. It's partially observable if the sensors can only see a fraction of the state, yet memorizing past measurements give us additional information of the state that is not readily observable right now. So in any game, for example, where past moves have information about what might be in a person's hand, those games are partially observable and they require different treatment. Very often, agents that deal with partially observed environments need to acquire internal memory to understand what the state of the environment is, and we'll talk extensively when we talk about hidden Markov models about how to structure such internal memory. A second terminology for environments pertains to whether the environment is deterministic or stochastic. A deterministic environment is one where your agent's actions uniquely determine the outcome. So for example, in chess, there's really no randomness when you move a piece. The effect of moving a piece is completely predetermined, and no matter where and when you move the same piece, the outcome is the same. That we call deterministic. Games with dice, for example, like backgammon, are stochastic. While you can still deterministically move your pieces, the outcome of an action also involves throwing of the dice, and you can't predict those. There's a certain amount of randomness involved in the outcome of dice, and therefore we call this stochastic. Let me talk about discrete versus continuous. A discrete environment is one where you have finitely many action choices and finitely many things you can sense. So for example, in chess again, there's finitely many board positions and finitely many things you can do. That is different from a continuous environment where the space of possible actions or things you could sense may be infinite. So for example, if you throw darts, there's infinitely many ways to angle the darts and to accelerate them. Finally, we distinguish benign versus adversarial environments. In benign environments, the environment might be random, it might be stochastic, but it has no objective on its own that would contradict your own objective. So for example, weather is benign. It might be random, it might affect the outcome of your actions, but it isn't really out there to get you. Contrast this with adversarial environments, such as many games, like chess, where your opponent really is out there to get you. It turns out it's much harder to find good actions in adversarial environments where the opponent actively observes you and counteracts what you're trying to achieve, relative to benign environment, where the environment might merely be stochastic, but isn't really interested in making your life worse. So let's see to what extent these expressions make sense to you by going to our next quiz. So here are the four concepts again: partially observable versus fully, stochastic versus deterministic, continuous versus discrete, adversarial versus benign. And let me ask you about the game of checkers. Check one or all of those attributes that apply. So if you think checkers is partial observable, check this one, otherwise just don't check it. If you think it's stochastic, check this one. Continuous, check this one. Adversarial, check this one. If you don't know about checkers, you can check the web and Google it to find out more information about checkers.